guys, Ben here from FurtherYourMaths. Follow us on Twitter at FurtherYourMaths. Now today I'm going to be working on the second part of differentiation. This involves finding the equation of a normal and finding the coordinates of stationary points on the graph. Let's start with the stationary points. Now what are stationary points? Here you can see a quadratic graph, and all quadratic graphs have one stationary point. And the stationary point is where, if you drew a tangent to the point, the gradient to the tangent would be 0. So, for example, this would be the stationary point on this graph, as if you drew a tangent to it, it would look something like that. The gradient to that tangent would be 0. Now, for a cubic graph, you have two stationary points. So, let me show you them. This is the first one, and this is the second one here. Because if we drew tangents to these points, like I'm doing so now, those tangents would be straighter, but they'd have a gradient of 0. And that's what stationary points are. If you drew a tangent to stationary points, it would have a gradient of 0. So how do we find the coordinates of these stationary points? Now here we have a typical cubic equation. So let's start by differentiating it to find out the equation to find out the gradient. If you don't know how to differentiate, I'd suggest going back to our previous video and revising that before you watch this one. So now let's differentiate. I'm going to do this quickly. So dy over dx equals x squared minus x minus 20. Right. And now what we need to do is work out the coordinates of the stationary points. Stationary points are where, if you drew a tangent to that point, the gradient of the tangent would be 0. And if dy by dx is the gradient of the tangent, surely that means that dy divided by dx would be 0. Which then in turn would mean that the equation I just wrote out, x squared minus x minus 20, would equal 0. So now we use our skills from GCSE maths to work out what x equals. So we could do this by factorising. It's what I'm going to use. You can use completing the square, the quadratic equation. It's up to you, but I'm going to use factorising because it's the easiest one. So we find out the multiples of 20, which are 1 and 10, 1 and 20, 2 and 10, 4 and 5. The ones that would go to make minus x would be 4 and 5. So if we draw our brackets, we've got x, 4, x and 5. Now all we need to do is put the symbols in. To get minus x, we'd have to put minus 5 and plus 4. And that, of course, equals 0. Now, if we use our skills from higher end GCSE maths, we know that one of these two brackets must equal 0. And for x plus 4 to equal 0, x must equal minus 4. And if x minus 5 equals 0, then that means that x must equal 5. So that means that the 2 points on this cubic graph, where the two stationary points on this cubic graph have an x coordinate of minus 4 and 5. So if I take the cubic graph here, the coordinate of this stationary point and this stationary point must be minus 4 and 5. Now all we need to do is work out the y coordinate. So what we do is we take the x coordinates we've just found and put them back into the original equation. So we'd replace x with 5 and x with minus 4. Now, I haven't quite got enough time to go through all that. You know how to do it. You did it in GCSE maths, replacing numbers into x. So if you replace them in, what you get for minus 4, what you'd get is 56 and 2/3. So you get 56 and 2/3. And then for the other x coordinate, which would be 5, you get minus 64 and 5/6. So now those are the two coordinates of the stationary points. The first stationary point has a coordinate of minus 4, 56 and 2/3. The other stationary point has coordinates of 5, minus 64 and 5/6. So that's stationary points. That's how to find out the coordinates of two stationary points. Now let's go on to the equation of normals. Sorry, the gradient of normals. Now we know a tangent is where if we picked a point here, the tangent would be here, and that's a tangent. It's a point that touches a curve. It's a line that touches a curve at only one point. Now, what a normal is a line that goes perpendicular to the tangent. So the normal of this tangent here goes something like this, an angle of 90 degrees, crossing at the point that you've chosen. Mine's a bit off, I apologise. But yeah, so that's what a normal is. Now, what you need to know for this FurtherMaths qualification is to find a line perpendicular to another line. You get the gradient of one line and do minus 1 divided by the gradient. Right, I'll show you now. So what I've done is, I've got this cubic graph here. Here's one that I prepared earlier. You have the cubic graph here. I've worked out dy by dx, and I've chosen the point where x equals 4, and the gradient of the point, the gradient of the tangent to the point where x equals 4 is 70. Right, so we now have the gradient of this line here. So now what we need to do is do what I said before. So to work out the normal, what we've got to do is minus 1 divided by 70. And that equals minus 1 over 70. So that means that if this line, this tangent here, had a gradient of 70, this normal line here would have a gradient of minus 1 over 70. So that's how to work out the normal. So the normal is perpendicular to the tangent, and to work it out you do minus 1 over the gradient of the tangent, and that will give you the gradient of the normal. So thank you very much for listening. I hope you understood that. If not, go down to the bookmarks just underneath this video and you can go watch 30 minutes again. Well, thank you very much for watching, and good luck.